Hello friends, today we will be learning how to solve similar triangles. This is a very important part of high school geometry, similar triangles. You all have a fair bit of idea about it. But today we will just learn the basics, how to solve two similar triangles. As you know, the triangles which are similar shape, they are called similar triangles. So you can see that triangle ABC and DEF, they have similar shape. So we call them as similar triangles. So we represent it like this. ABC is similar, this is the symbol of similarity to DEF. What exactly do we mean geometrically when we say that the two triangles are similar? So geometrically it means two things, that the sides are proportional. So AB by DE is equal to BC by EF is equal to AC by DF. Secondly, the angles are the corresponding angles are equal. Angle A equal to angle D, angle B equal to angle E, angle C equal to angle F. So these are the two outcomes of these two triangles being similar. The sides are proportional and the corresponding angles are equal. So you can also say that two triangles which are equiangular are similar triangles. Now, if you are given two triangles to begin with, suppose you are given triangle ABC and DEF and you are asked to verify whether they are similar. In that case, there are three ways to prove similarity. The first is you prove that the corresponding angles are equal. So angle A equal to angle D, angle B is equal to angle E, angle C is equal to angle F. So this is the first method to prove similarity. This is known as AAA. So if you can prove that the angles are equal, then in that case the two triangles are similar. The second method is you prove that the corresponding sides are proportional. So to prove the corresponding sides are proportional, you basically have to prove that AB by DE is equal to AC by DF equal to BC by EF. If you can prove this, then also it is confirmed that they are similar. So we call this as SSS, side, side, side. The third way of proving similarity is you take any pair of angles, for example angle A equal to angle D and angle B equal to angle E, and in addition you may take any one pair, angle A equal to angle D, and in addition you prove that adjacent sides or the arms of the angle are proportional. So this is known as SAS. So I repeat, the third method of proving similarity is you prove any one pair of angles is equal and the sides adjoining those equal angles are proportional. So if angle A equal to angle D, then AB by DE is equal to AC by DF. So there are three ways of proving similarity: AAA, SSS and SAS. Suppose there is a right angle triangle let's say there is a right angle triangle and BD is perpendicular on the hypotenuse. So ABC is a right angle triangle where BD is a perpendicular on the hypotenuse. Let's say this angle is theta, as because this is 90, so this is 90 minus theta. Similarly, this is theta, so this is 90 minus theta, and this is theta. Now if you notice there are three pairs of equiangular triangles in this figure: ABD, BCD and ABC. You will see that ABD, BCD, ABC, all three triangles have theta, 90 minus theta and 90. Now, what you can do is, you can make a chart like this: theta, 90 minus theta, 90, and you just mention which are the corresponding sides. What do I mean by that? For example, in triangle ABD, opposite theta is AD. In triangle BCD, opposite theta is BD. In triangle ABC, opposite theta is AB. What about 90 minus theta? In triangle ABD, opposite 90 minus theta is BD. Then in BCD, opposite 90 minus theta is CD. And in ABC, opposite 90 minus theta is BC. And in triangle ABD, opposite 90 is AB. Then in BCD, opposite 90 is BC. And in ABC, opposite 90 is AC. So you can see that this is a very good way of deciding how to take the proportionality of the sides. Just set up all the angles and take the sides opposite to those angles. Now what we can do is, we can take similarity two triangles at a time. So suppose we take ABD and BCD, suppose, then we can say like this, that AD by BD is equal to BD by CD. So you will notice that AD by BD is BD by CD. So this gives us a very, very important relation. BD square is AD into CD. So by taking similarity of ABD and BCD, we got this relation. Similarly, if we take ABD and ABC, right? Suppose if we take ABD and ABC, in that case we can say that AD by AB is equal to AB by AC. So that gives us AB square is equal to AD into AC. And thirdly, if we take BCD and ABC similar, then we can say that CD by BC is equal to BC by AC. So BC square is CD into AC. So these are the three important relations we get by taking the similarity two at a time. And now you will notice one thing, that out of the three, if you take, suppose these two, the second one and the third one, and if you add both of them, then AB square plus BC square is equal to AC into AD plus CD. So it is equal to AC square. So this is the very, very well known Pythagoras theorem. So we have been able to prove Pythagoras theorem by making use of these relations. This question also gives us a very important insight how to decide the proportionality of the sides. We know the two triangles are similar, but how do we decide the proportionality of the sides? So this gives us an idea how we can do it. Suppose you have a triangle, suppose the triangle's name is ABC, and in this triangle DE is parallel to the base. So if DE is parallel to the base, we can say that if this is theta, this is also theta, and if this is alpha, this is also alpha, and in that case triangle ADE is similar to triangle ABC. Why? Because you can see that this is theta, this is also theta, this is alpha, this is also alpha, and angle A is common to both ADE and ABC. So ADE and ABC are similar triangles. Once again, what you can do is you can just write down that in triangle ADE opposite of theta is AE, and in ABC opposite of theta is AC. In triangle ADE opposite of alpha is AD. In triangle ABC opposite of alpha is AB. In triangle ADE opposite of angle A is DE, and in triangle ABC it is BC. So this is the relation that we are getting. Now what we are going to do is we are going to take the ratios like this: AC by AE is equal to AB by AD. AC by AE is equal to AB by AD, right? And then we will subtract 1 from both sides. So you just subtract 1 from both sides. So AC by AE minus 1 is equal to AB by AD minus 1. So you will get AC minus AE, that is EC by AE, and AB minus AD, which is BD by AD. So you are getting EC by AE is equal to BD by AD. So when a line in a triangle is parallel to the base, it divides the two sides proportionately. So in this particular diagram, DE is parallel to the base. So we get EC by AE is equal to BD by AD. This particular equation is called basic proportionality theorem. And it is also known as the Thales theorem. So Thales was the famous Greek mathematician who is credited with the discovery of this particular theorem, and in his name we call it Thales basic proportionality theorem. This is a very important theorem with a lot of usage in various sums of similar triangles. What we'll do is we'll just have a look at one of them right now. Suppose you have a triangle ABC, and in this triangle ABC, AD is the bisector of angle A. AD is the bisector of angle A. Now what you do is you draw a line CE parallel to AD, and incidentally E lies on AB produced. I repeat again, you have a triangle ABC, AD is the bisector of angle A, you draw a line CE parallel to AD and E lies on AB produced. So since these two are parallel, if this is theta, this is also theta, and again due to parallel, if this is theta, this is also theta. So AE and AC both are equal, but if AD is parallel to EC, then by using Thales theorem, we are in a position to say that AB by AE is equal to BD by CD. So using Thales theorem, we can say that AB by AE is equal to BD by CD. But we know that AE and AC are equal, so AB by AC is equal to BD by CD. Now this is an extremely important result because it tells us that the angle bisector divides the opposite sides in the ratio of the other two sides. So in any triangle, if you have an angle bisector, it divides the opposite side in the ratio, in the same ratio as the other two sides. So BD is to CD is AB is to AC. So you can see that by using Thales theorem, we are able to solve these questions quite easily. Suppose there are two similar triangles. Suppose there are two similar triangles ABC and DEF. I have drawn two altitudes AX and DY. So because of similarity of the two main triangles, if this is theta, this is also theta. So ABX and DEY are similar. So we can say that AB by DE, AB is opposite to the right angle, DE is opposite to the right angle, is equal to AX by DY. Now let's say we want to find out the ratio of area of ABC to the area of DEF. Area of ABC to area of DEF. So you know that the formula is half base into height. So half AX into BC divided by half DY into EF. So you cancel the half, and AX by DY is the same as AB by DE, and this is BC by EF. But you have been told right from the beginning that the main two triangles ABC and DEF are similar. So we can write AB by DE as BC by EF. So the answer becomes BC square by EF square. This is a very, very important result, that the ratio of the areas of two similar triangles is equal to the square of the ratio of their sides. So that brings us to an end of this session of similar triangles. You may also watch the video on Pythagoras theorem, which is related to this topic.